So let's get started on using a computer to do some of the drudgery and the tedium of the linear algebra we want to do instead of us having to do it for ourselves. So I'm going to use CoCalc here. So if you go to CoCalc.com, this is the landing page, and you can set up an account if you want to, but you don't have to. So I'm just going to start it using an anonymous account. All right, so once I have this anonymous account, I'm going to go to View My CoCalc Projects. And I need to make a new project because this is a brand new anonymous account. So I'm going to call this Intro to Sage. Go create the project. I'm going to click Start Project here. Give it a second to load everything up. All right, and now I need to create a Sage worksheet. So it's one of the options here, Sage worksheet. Of course, you could use CoCalc for all sorts of other stuff, but let's do a Sage worksheet. Okay, this is the basics of what a Sage worksheet looks like. There's an input line. Lines are numbered. It's number 1 so far. Let's go ahead and see what Sage can do. So the first thing Sage can do is arithmetic. So let's try what's 1 plus 1. If we hit ordinary enter, then we get a new line. If we want to evaluate that, we need a shift enter. Notice the first time you evaluate any command at all, it takes kind of a little bit of time. That's not because Sage is stupid. It's because it's waking up. So now we do 2 cubed, and we get an instantaneous answer of 8. All right, we're going to need to refer to things with names. So how does naming work in Sage? It's very easy. You say something like a equals 2. Now, if you hit shift enter to evaluate that, you don't get anything because you didn't ask Sage a question. You just said a is equal to 2. If you want to know that Sage understood you, you should ask, hey Sage, what's a? Oh, a is 2. All right, then you can do fun stuff like what's a squared? A squared is 4. You can make other definitions. Let's say b is 6 and c is 12. And let's ask what's a plus b? Notice here, I've got 4 input lines. And when I evaluate, the first 2 lines are just definitions, so they don't ask Sage to do anything. But the second 2 lines are what's a plus b and what's a plus b plus c. You can see each output is on a successive line. Let's ask Sage a question. Is b equal to c? Notice I'm using 2 equal signs there. That means I'm asking, are these 2 things equal, rather than declaring that they're equal? And the answer is no, they're not. We're going to do some symbolic manipulations. Sage is really good at these as long as you tell it who counts as a symbolic variable. This is a bit like when you first started taking multivariable calculus and you had to get used to the fact that letters like A and B and C could be variables. Sage is the same way. It doesn't know what a variable is. Well, it knows what X is, but it doesn't know any other variables. So we got to tell it. That's easy to do. You just make a list of things that you want Sage to think are variables. It doesn't matter how many there are. We just make a list of them and make sure that Sage reports back to us, oh, I know these things are all variables now. That's going to allow us to do things like define a symbolic function, like t cubed plus 2t. Again, it's a definition that we just made, so Sage doesn't report anything back to us. Let's ask, what's f of t? Oh, f of t is t cubed plus 2t. We could also ask Sage, what's f of x? Because x is another one of our variables. Oh, it's x cubed plus 2x. So Sage knows about replacing one variable with another, no problem. What's f of 4? It's 72. Let's ask Sage what f is by itself, and you'll notice that f is a symbolic function. It takes in a variable t and spits out this expression, right? Notice the result of evaluating just f versus evaluating f of t is slightly different. Those are different types of things. This one is called a symbolic expression. This one is called a symbolic function, and they are different gadgets. All right, what can Sage do with symbolic functions? Hey, Sage knows how to differentiate. Notice that if you differentiate a function, you get a function back, which means that you can evaluate the thing that you got back. So diff of f at 3, or as we would say, f prime of 3, is 29. Sage also knows how to integrate. We're going to integrate f of t as t goes from 0 to 3. Takes it a second to fire up the old integrator machine. There we go, 117 over 4. We could also integrate f of x from x going from 0 to 3. And of course, we get the same answer. That's no surprise. Let's see what happens if we integrate f of x as t goes from 0 to 3. And before you hit Shift-Enter, you should try to predict what's going to happen. And that's what happens. And what you should do here is satisfy yourself that that's the right answer. That's what you should get. Now let's integrate f of t as t goes from 0 to x. And you notice that we get an expression in x, which is what we should get, again, mathematically speaking. Now the fact that integrals can be symbolic means that you can ask Sage to do multivariable integration. So let's say that g of xy is x squared plus y plus x times y, and try to integrate g as y goes from 0 to x. So you're going to get an expression in x. That makes sense. We integrated out the y's. Now that's an expression in x, so we could integrate it. So let's just do that whole thing at once. We're going to integrate the integral. And we get a number, which is what we should get.